All right. So what was the idea about Zeno's paradox?
So I think the book just sort of talked about just the basics of Zeno's paradox, and so
why don't you take us halfway through it?
Okay, so I will explain it. So you're at one end of like a road or a room or something.
Okay.
So you're here and you want to get over here. And so Zeno said that before you get there, you have to get halfway. You have to get to the halfway point and pass it. And then once you're here, you have to get to the halfway point of that.
Right.
So you have to go here. And then once you're there, you have to go here, and then you get infinitely close, but never there, because you have some finite distance to go, and so the idea is that you can't actually cross this room.
Okay. How can you disprove that?
Well, you can just walk across the room.
Okay.
But...
Alright, so it seems easy to disprove that you can't walk across a room.
Just because you can just walk across a room.
Yeah.
But, say, if you call the length you're trying to walk 1, so like, maybe it's a mile or something, 1 mile, you can look at it in sort of these steps. You have to go a half to get here, and then a fourth, and then an eighth, and then a 16th, and so on. And so the sum is a half plus 1/4 plus 1/8 plus 1/16, and so on. And then the idea is that this is eventually equal to 1. This sum is eventually equal to 1, and so you actually can cross the room if you take an infinite number of steps.
I see.
So let's see.
Is that what happens when you cross a room? Do you take an infinite number of steps?
No, but no. But I guess this would be a way to disprove the paradox.
Okay.
Because you'd have to like step at all of these points for the paradox, and when you're just walking across the room, you'd pass over infinitely many of them in like the last step.
Now, were you going to show how the series sums to be 1? Or is that what you wanted to talk about in the third part with the infinite series, just generally?
No, I think I can show that this is equal to 1. So you set it to x, and then let's see. You can divide every term by 2, and so you're left with a 4th plus an 8th plus a 16th plus a 3rd, or 1/32. And this is generally how we deal with a lot of infinite series. And then this equals x/2.
Okay. That's pretty clever.
Now we can see that we have a lot of terms lining up this way, so we can subtract away x/2.
Alright.
And the 4th will cancel with the 4th here. So every term has a match. Every term in x has a match in x/2 except for 1/2. And so all you're left with is 1/2 equals x minus x/2, so x/2. And then we just multiply by 2 again, so we get 1 equals x. And so this infinite series sums to 1.
Cool. Very cool, actually. Alright, well that's neat. Let's talk generally about infinite series now.